Intelligent life has had countless chances to appear. So why is the universe silent? The Great Filter offers three unsettling possibilities, and each puts humanity in a very different position. Look at the night sky and assume one unsettling fact: intelligent life should have had countless chances to appear. So why do we hear nothing? The answer may reveal where humanity sits in cosmic history. In the next 8 minutes, we'll separate what astronomy actually knows from one sharp thought experiment, the Great Filter. Then we'll test whether that filter lies behind us, ahead of us, or nowhere at all. The established background is simple. The Milky Way contains vast numbers of stars, many with planets. Some worlds are ancient. Even slow interstellar expansion could, in principle, spread visible activity across a galaxy. Yet our telescopes haven't confirmed an alien signal, probe, engineered star, or industrial fingerprint. That silence creates the Fermi paradox. High expectations collide with empty observations. It's attention, not proof of absence. Before we explain the silence, there's a trap. We barely sample the cosmic haystack. Radio searches cover limited frequencies, directions, and times. A quiet receiver may simply be listening badly. Still, the question survives because advanced life might leave more than radio. Heat, unusual atmospheric chemicals, artificial light, or large structures could betray technology. So far, none has become a confirmed technosignature. Now for the thought experiment. Imagine a chain from dead chemistry to a civilization visible across space. If the universe looks empty, perhaps one link in that chain is extraordinarily hard to cross. That hard step is the Great Filter. It isn't a discovered object or accepted answer. It's a reasoning tool. Somewhere between simple matter and galaxy-spanning technology, most possible histories may stop. The first candidate sits near the beginning, life itself. Planets may be common while the chemistry that starts self-replication is fantastically rare. Earth would then be unusual before evolution really begins. Or microbes could appear often. Yet complex cells almost never form. On Earth, simple life dominated for an immense stretch. The jump to cells with intricate internal machinery may be the bottleneck. Another possibility is multicellular complexity. Stable bodies, specialized tissues, and rich ecosystems require cooperation without total collapse. Intelligence isn't evolution's promised destination, it's one narrow result among many workable strategies. Even clever animals may never build radios. Technology needs manipulators, energy sources, social learning, and environments where knowledge accumulates. An ocean civilization might think brilliantly while finding fire almost impossible. If those early barriers are rare enough, humanity has encouraging news. The worst filter could be behind us. But that comfort rests on one sample, Earth. One example can't reveal cosmic odds. Now flip the timeline. Maybe life and intelligence are common, but technological civilizations destroy themselves. Nuclear war, engineered disease, ecological breakdown, or uncontrolled systems could end the detectable phase quickly. That idea sounds dramatic, so keep the logic clean. Astronomy hasn't shown that civilizations self-destruct. The Great Filter merely asks whether repeated failure could explain why old, obvious technological cultures aren't seen. Survival may fail without extinction. A society could abandon expansion, turn inward, become energy efficient, or communicate in ways we can't recognize. The galaxy might be inhabited yet visually boring from far away. Distance adds another veil. Signals weaken, stars obscure lines of sight. And civilizations may overlap for only short periods. Two intelligent species can share one galaxy but miss each other by millions of years. Then there's our assumption that expansion is inevitable. Perhaps crossing between stars remains expensive and unrewarding, even for advanced engineering. A civilization might explore locally and never paint the galaxy with machines. So the silence has competing explanations. Rare beginnings, difficult complexity, fragile technology, deliberate quiet, poor timing, or weak searches. The paradox doesn't choose among them. Evidence must do that work. Mars matters because it may preserve a second sample. If ancient Martian life began independently, biology could start easily. That would shift attention toward later steps. Though shared material between planets complicates the inference. Icy moons offer another test. A separate biosphere beneath an alien ocean would suggest life emerges in very different settings. Exciting, yes. But in Great Filter logic, common microbes could make later silence more troubling. Exoplanet atmospheres provide a wider census. Telescopes can search for chemical combinations that biology might sustain. Any claim needs caution, because geology and starlight can mimic signals, and remote spectra contain ambiguities. A confirmed biosignature wouldn't reveal intelligence. But many living worlds with no technology would narrow the mystery. We'd learn that the road begins often, then apparently loses travelers somewhere farther along. Technosignatures test the opposite end. Radio pulses, laser flashes, industrial gases, or waste heat would show that technology sometimes becomes visible. One robust detection would transform the paradox from silence into demographics. But absence is harder to interpret. Every search has boundaries, sensitivity, wavelength, sky coverage, duration, and assumptions about alien behavior. A null result trims possibilities, it never surveys every conceivable civilization. Suppose future missions find Mars, an icy moon, and nearby exoplanets all sterile. That hypothetical pattern might favor an early filter. It still wouldn't prove Earth is unique, because the sample remains local. Now suppose simple life appears everywhere we look, while intelligence leaves no trace. In that hypothetical case, the filter moves later. Complexity, technology, longevity, or detectability becomes the sharper suspect. The most unsettling discovery might be ruins, evidence that technological life arose repeatedly and ended. That's pure speculation today, but its meaning would be immediate. The dangerous step could sit after invention. Still, the great filter can mislead us if we treat one chain as universal. Alien evolution may follow routes we haven't imagined, while our categories of life, intelligence, and civilization reflect Earth's peculiar history. The paradox also depends on what counts as visible. A culture using little energy might escape our surveys. A network of small probes could hide in ordinary data. Silence may describe our instruments, not reality. So what should change our minds? Independent life would update the early steps. Complex organisms would update later ones. A verified technosignature would prove at least one other civilization crossed far more of the chain. Until then, the honest answer is a probability cloud, not a verdict. The great filter organizes our ignorance. It tells us which discoveries matter most, and why even a microbe could alter humanity's self-image. Tonight the Milky Way remains quiet to our instruments. The next decisive clue may be modest, a Martian sediment, an ocean moon sample, or one stubborn spectral feature that refuses every non-living explanation.